Every engine manufacturer gives us this number here, which means that it's probably pretty important, right? Be honest now, how many of us really understand what this number means though? I mean, how can we use it for our advantage, and how does this affect the performance of our boats? Are we leaving some performance on the table? Well, as long as you hit that free subscribe button, we'll move into 3 basic but crucial things to consider when it comes to a boat, its performance and efficiency. Number 1 is weight, then torque, and then power. The biggest problem to overcome with a boat is that we want to put as much stuff as possible in them and carry as many people as possible without sacrificing performance or efficiency. With every item and person, we add weight to the boat, leaving us with a super heavy object that we need to push through the water, overcoming the suction or drag of the water and arriving at whatever speed it is that we want to get to, or our top speed, and factoring in how long it takes us to get there being our hole shot. This is where torque comes into play. Now, as a simple example, you can think of torque as leverage when it comes to physics. Take this ratchet as an example. The thicker the ratchet and the longer the handle, the more leverage we're going to get. The more torque we will have to loosen something or tighten it, and the longer the handle, the more torque or leverage we will get. Now, in a weight example, the farther we get away from the item that we are trying to move, the more weight we will be able to move. And that's basically how torque works. With that same understanding applied to a propeller, the larger the diameter of the propeller, the more torque we will have to move a heavier boat. I just want you to have that thought in mind as we go along with the story here, because that will play a huge part for you later on. Let's look at some numbers here so that way we can start putting this into some practical applications. You'll notice that most of the high horsepower engines have a lower gear case ratio number. But what does this number even mean? Without applying how you can use this to your advantage yet, the number is a reference to the size of the gears that are in the lower unit. Outboards use lower units to transfer the power of the engine to the lower unit, and they utilize a thing that is known as gear reduction, which is what our numbers that we are talking about here reference. Here are the gears from a lower unit that will help us understand how this works. This is the pinion gear, which is going to be the input gear because it is getting power directly from the drive shaft of the engine. If we count the teeth on it, it has 13 teeth. Then we also have the forward and the reverse gear, which are going to be our output gears because they output the power coming from the engine to the propeller shaft, which turns our propeller to move the boat. And these gears both have 27 teeth on them. Don't worry, I counted them so you don't have to. Now, if we divide 27 by 13, we get 2.07, which means this gear case has a gear ratio of 2.07 to 1. Now, what that means is that for every time our pinion or input gear or engine turns around 2.07 times, the larger gear, whether that be the forward or reverse gear or the output gear, is going to spin the propeller around once. And that's what is called gear reduction. Now, why this is done takes us back into our discussion of torque and or leverage. And I say leverage because it's going to allow more people to understand the terminology and the concept of what is going on here and how it is going to apply to you. In boating, our concern is again in moving the weight of the boat through the water, but also in the time that it takes us to get on plane and the top speed that we can achieve when doing this. Speed is why most outboards are run with gasoline and not diesel. With our understanding of torque and leverage being the distance between the middle of, say, a wheel and the outside of the wheel, whether that be the gear, a propeller, or applying this to the engine and its piston and piston rod, the distance between the top of the piston and the crankshaft is basically what creates and gives us the torque that is produced by the engine and then given through the drive shaft to the lower unit pinion gear and then to the forward or reverse gear and ultimately to the propeller. Without getting off track and too into it, most diesel engines have a longer stroke which aids them in producing more torque, but the longer stroke makes them run at a much slower RPM, whereas gasoline outboards have a shorter stroke, giving less leverage or torque but a higher RPM. With the increased RPM, engines can get a higher horsepower, which isn't the only factor in horsepower, but we aren't going to get into exactly what is horsepower today. Just understand that with the increased RPM, we do get an increase in horsepower, but we still also need to take into account our gear ratio as well as the addition of the propeller diameter and the propeller pitch. This is why more horsepower doesn't necessarily mean more speed or better performance, a better hole shot, or an increase in our fuel economy either. Because you can produce all the horsepower that you want from the engine, that doesn't necessarily mean that it is getting transferred and applied to the water where we need that thrust, that torque, or that leverage from the propeller in order to push the boat through the water. Bringing us back to our gear ratio. In a 2-to-1 gear ratio, the first number again represents how many times the propeller is going to spin around compared to how many times the engine is going to spin around, being 1 and the second number. Notice that 2-to-1 has a higher number, which most people will say is a higher ratio because it is a higher number than 1, right? But that is also going to depend on who you are talking to, because the lower the number, the faster the prop shaft is going to be spinning, which some will consider to be a higher reduction because the prop shaft is spinning quicker. And that is why we're focusing on the concept, so that way you understand what the number means, period, regardless of how you say it. The higher the first number, being the number of times the propeller is going to spin around compared to the number of times the engine is going to spin around, the more reduction you have. This means a slower spinning propeller. Higher first number, slower propeller, allowing you to spin a bigger propeller diameter that will give you more thrust, more torque, more leverage, more ability to move more weight, a better hole shot, and less slip. The bigger the number, the bigger the prop. But with a bigger propeller, you are also adding drag. You need more torque at the prop shaft, meaning higher RPM out of the engine. Whereas a lower first number, say a 1.75 to 1, means a faster spinning prop shaft, where you can run a smaller diameter propeller with a higher pitch, giving you similar speeds at lower RPM and ultimately giving you a better top end speed and a higher RPM from the engine overall because you have less drag and more slip. With this though, you have less reduction, which gives you that prop slip, decreasing your hole shot and getting less torque at the propeller. Less reduction gives us less torque and less thrust. And this is why, because we are spinning a smaller propeller. We'll find that most higher horsepower outboards have a smaller gear case ratio, somewhere around the 1.75 to 1 or 1.85 to 1 ratio. And then the lower horsepower engines will have a higher ratio into the 2s. Putting all of this into a practical application, take a look at a Yamaha F60. The normal F60 has a ratio of 1.85 to 1. But when we look at the F60 high thrust model, it has a ratio of 2.33 to 1, and pretty much everything else about the engine is the same. Hopefully you are understanding a lot of this a lot better, because you could probably see why they call it a high thrust engine, because it has a higher gear ratio of 2.33 to 1, which means it can spin a bigger propeller and give you more thrust in order to move more weight. Think about it in this application of a pontoon boat that can carry 15 people. With the smaller prop or the smaller ratio in the gear case, you're just going to blow the prop out because it's a smaller prop and there's too much weight on the boat. Whereas with the 2.33, you can use a larger propeller, which will give you more thrust, more torque to move that whole boat with the entire neighborhood on it all around the marina wherever you want to go. And now that we understand that a higher ratio is better served to run a bigger propeller, providing more thrust and more torque to the water through the prop at a slower speed to move more weight, the application and the weight of the boat is the main concern. If you want to get speed, you sort of want a smaller ratio, right? A faster prop and a larger pitch, pushing a lighter boat, and if you have a heavier boat, you want a larger ratio. That's why when we look at the Mercury 600, it has a 2-speed transmission, with the first gear being a 2.95 to 1 and the second gear being a 2.5 to 1. And you'll notice that they have a duo prop setup with a massive 16 3/4 inch diameter prop. The design of the engine is to move a massive amount of weight and still be able to achieve as much top speed as possible. That's why the engine also turns up to 6,400 RPM, where say comparably a Yamaha 450 XTO has a top RPM speed of 6,000 RPM and runs a 1.79 to 1 gear ratio. Lower gear ratio number, higher prop shaft speed. Both engines are designed to move weight, but based on the amount of horsepower, the 600 can afford to sling that higher gear ratio and that larger duo prop setup, with keeping as much speed as possible with that extra RPM and with that extra horsepower supplying more torque down to the slower spinning prop shaft. Now this is also important to know about because it can cause premature failure if your boat is propped improperly and you are running the wrong gear case ratio in the wrong application. Like say you are running a pretty light boat with a lot of horsepower and you have a lower unit that has a high gear ratio like a 2.5 to 1 instead of a 1.75 to 1, and you just run a really aggressive propeller to compensate for just blowing out the prop all the time with that higher horsepower in order to get you the performance that you expect out of that higher horsepower engine. You may be able to dial it in and get it to run normally, but the added torque from the propeller on the gear case is going to eventually destroy the lower unit. And vice versa, if you're running a really heavy boat and you're using a 1.75 gear case opposed to a 2.33, regardless of the amount of horsepower that you have, you're going to have to really load the engine down with a really large propeller to get the performance out of the boat. And that's what makes propping out the boat so important. And understanding that more ponies doesn't necessarily mean more speed.